In this problem, we're first asked to find the points of intersection, A and B. Since they are points of intersection, we just set the two equations equal to each other. 2 over x is equal to 3 minus x. To solve it, I would multiply both sides by x, giving me 3x minus x squared. Now this is quadratic, so I'm going to set it equals 0 by bringing the right side over to the left side. I'll add the x squared, subtract 3x, and then my right side is 0. That can be factored into x minus 2 and x minus 1. So I have two x coordinates, one at positive 2 and one at positive 1. A, since it's the point that's on the left, is going to have the x coordinate of 1. Its y coordinate is going to be the same whether I plug that 1 into f of x or g of x. So I'm just going to take 2 divided by 1 and get 2. For the point B, its x coordinate is 2 since it's to the right. And when I plug that in, 2 divided by 2 is 1. So those are our 2 points. Next, we're asked to complete the representative rectangle. So it's drawn in the picture right here. And the base of that rectangle we say is delta x, because that's representing one of the many Riemann rectangles that are in there to help with the Riemann sum. The height of this rectangle, though, we think of that as this vertical distance, right? And vertical distance would be y1 minus y2, the y coordinates of each of them. And don't take the y coordinates, those 2 points that we just found, because those are very specific points. We're talking about generally any x value along the way, what is the height in terms of x. And I think of it as, since we're going to do y1 minus y2, y1 being the one that's on top. And that one that's on top is the line, 3 minus x. From that, I'll subtract the y coordinate that's on the bottom, which is going to be that f of x, so 2 over x. And this expression, 3 minus x minus 2 over x, is going to be the height of that rectangle. We use this rectangle to help us create our definite integral, because we'll just do the base times the height. The height is 3 minus x minus 2 over x. And the base is delta x, which, when we have infinitely many of these, turns into d of x. And our definite integral is going to go from point A over to point B. And in terms of x, point A has an x coordinate of 1, and point B has an x coordinate of 2. Now the last thing to do is to evaluate this definite integral in order to find the area. So we integrate each piece. The integral of 3 is 3x, minus the integral of x is 1/2 x squared. And the integral of 2 over x is 2 natural log of x. We'll evaluate this from 1 to 2. So first, let's plug in 2. 3 times 2 is 6. Minus half of 2 squared is 2. Minus 2 natural log of 2. From that, I'll plug in 1 and subtract, so we'll have 3 minus a half minus 2 natural log of 1. And it's all simplifying now. 4 minus 2 natural log of 2 minus 3 minus a half is 2.5. Natural log of 1, though, is 0, so this term is just going to turn into 0. 4 minus 2.5 is 1.5, so 3/2 minus 2 natural log of 2 is going to be the area of the region bound by f of x and g of x.